Had a quick question for you experts on the EEV blog. I am going to do a video on measuring in-ground inductive loops and a little demonstration on loop detectors. And one of the things that we measure when we go measure an inductive loop is the inductance, of course. And I wanted to show the waveform of the output signal of my LCR. As opposed to the higher frequency output of a loop detector. And I was looking at it on my oscilloscope, and I was curious to see that the waveform, if you will, is being pulsed like this or turned on and then turned off every second or so. And I was curious, is that how a LCR is supposed to act? And if so, why is it doing that? I guess my suspicion is, although I know this is wrong, is that it's turning itself off so it could possibly measure an energized circuit, or it's turning itself off to measure some other component of the signal, something to do with either the quality or the dissipation or something like that. And those terms are something that I'm not 100% familiar what they are. So if somebody could answer the simple question of, is this how the output waveform is supposed to act? And if so, why does it do that? So here's the test setup that I've got going on. And this part is just an interactive part. This is just a sampler that is hooked up to a set of speakers. So when I'm demonstrating it, it can be a little bit more interactive. You could have funny sayings in it, or you could have just the regular access granted or try again or whatever the case may be. So as of this part of it is just hooked up to the output of the loop detector to trigger the input on this sampler, and then it'll play a sound, and I've got some sounds recorded into it. So I've got 120 volts energizing it, and then I've got a 120 volt loop detector, and it's got 2 relays and 2 inputs. And I've got the one input hooked up from the coil, and then I've got the output, which is this wire right here, hooked up to the play button on this little sampler. And what I wanted to do was take a look at the voltage over time and how it reacts when this coil has a piece of metal that changes the magnetic field. And I wanted to make sure that it was safe to actually energize the circuit with the LCR while it's being energized with the loop detector. The loop detector outputs a sine wave from 62K up to 78K. It has 3 different settings, and I believe that's in increments of 6K. So I want to be able to take something like this little single gang box here, and I want to be able to put it over the loop, and then I want to look at the waveform on the oscilloscope, look at the voltage on the oscilloscope, and see how all of those relate to each other. And what I want to see is if somebody would take a measurement out in the field, how all these different measurements interact with each other and how they relate to actually telling you whether the coil has the proper inductance, whether it is tuned, has the ability to be tuned to the loop detector, and those types of things. So if it's of importance, this is the setup that I've got going on. So this is what it will look like. You can see that the loop detector has a green LED showing you that it has power, and if it were flashing, it would show you some kind of status going on. And right below that, you'll see a red LED, and that comes on when it detects fluctuation in inductance, such as this.
Ooh, access granted.
So as you can see, I caused it to change the magnetic field and probably change the frequency of the loop detector output and change the voltage as well too. So I want to make sure that that it's okay to hook the LCR and up to the loop detector while I'm actually taking a measurement, and that's it. That's all I want to do is just demonstrate how a inductive loop works, and some of the principles that we would use in order to test it, such as resistance, inductance, and then one of the other things that we test out in the field is leakage. It's an insulation test where we send 500 to 1,000 volts through the wire and see if there's any leakage to ground. If not, then we pour water over it to help increase the conduction, and then run the test again at 500 and sometimes 1,000 volts to see if there's any change in the insulation resistance after we put water on it, and help the conductivity of any cracks in the insulation. So any input would be great. Thanks.
Yo, who dis? You mean dollars? Ooh, you make me so...
Couldn't have planned it better.